Hi Professor Chen, this is my first video for this week, and this video is about question 1, and let me introduce this question first. Find and draw the probability distribution function of y and probability density function of y in terms of f(x), which is probability distribution function of x, and the probability density function of x. And the diagram below this question shown us what the y equal to gx looks like, and yeah, we can tell from this picture here. When x less than 0, the gx equal to 2, and when x located in the range between the 0 to 1, the gx equal to 0, and when x in the range between 1 to 2, the gx equal to negative x plus 1, and when x greater than 2, the gx equal to negative 1. And there's also a diagram shown here, which is like this. Actually, it makes no use for us to solve this problem here, but we can draw the fyy and this fyy based on the diagram of x-axis here. And first, we already know that y equal to gx equal to this part, this big part, for different circumstances here. So we can just draw the diagram of gx based on this function here. So the function, the diagram looks like this. When x less than 0, the gx equal to 1, and when x in the range between the 0 to 1, the gx equal to 0, and when x greater than 2, the gx equal to y equal to negative 1, and in this part, when x greater than 1, less than 2, the gx equal to negative x plus 1, which is in this line here. So we can tell from this diagram here, the range of y is from negative 1 to 2. So when y located in the other range, other side of the range between the negative 1 to 2, the fyy, the probability density function of y, should be 0. So let's discuss this problem in several different circumstances here. The first is when y located in the range between the negative 1 to 0. So we can tell from this diagram here, when y in the range between the negative 1 to 0, it should be like this part, and this part correspond to the range between the range of x from 1 to 2 here. So the gx should be negative x plus 1, which is not constant. So we can just use this formula here to find out what fyy is, and so the x1 equal to 1 minus y, which should be the root of y equal to gx here. So we can just simply apply this formula here to find what the probability density function of this circumstance here, which would be the fx 1 minus y here. And we need to discuss several different special points of y. Why we have to discuss this? Because these different special y is inconsistent with this with the probability density function we already solved here. So we need to discuss it. The first part is when y equal to the negative 1. And we just need to solely discuss the probability of these different special y here. So the probability y equal to negative 1, we can tell from the diagram here, is equal to the probability when x greater than 2. So the probability y equal to minus 1 equal to the 1 minus fx2 here, looks like here. And when y equal to 0, we can also find the corresponding range of x in the diagram here. So the probability y equal to 0 equal to the probability when x located in the range between the 0 to 1, so it should be like this. And also the y equal to 2 should be like this. And so the fyy, the probability density function we've already discussed here, it should be in this big part here. And when y equal to -1 should be like this, and in the range between the -1 to 0 should be like this, and when y equal to 0 and y equal to 2, we've already discussed here. And the fyy equal to 0 otherwise means when y located in the range outside of these 4 different circumstances, the fyy should be 0. So we can just based on this the function here, we can just draw the diagram of fyy here. I'm sorry, this part should be fyy and this should be y. Yeah. So the several different special point we've discussed here is this when y equal to when y equal to -1 here is inconsistent with the probability density function here. We can just use the delta function, the diagram of delta function here, to show this. And these 1, 2, 3 different point we discussed here, it should be the delta function and inconsistent with this function. So we need to specially discuss. And every question, if it has a special point like this, we need to discuss it, because always they are inconsistent with the probability density function we already discussed when gx had a specific function, not a constant. So the second part is fyy. We need to discuss the distribution function of y. Here we need to this is the formula to find the distribution function of y by using the probability density function of y. So we need to integrate the fyy from the -infinity to y, so we can find the fyy here. And as before, we need to discuss several different circumstances here, because we already know the y should be located in range between -1 to 2. So when y located in the range outside of this range, the fyy should be 0. So so the first part is when y less than -1, the fyy, the probability density function, is 0. So correspondingly, the probability distribution function of this circumstance, this part should be 0. So this part is the first part is 0. And the second is we need to discuss when y located in the range between the -1, which equal to the -1, which include the -1 and less than 0. We need to discuss this range. So like I said before, this range is this range is includes the -1. So we need to use this function and this function here to discuss what the probability density function of this circumstance here. So we just use this formula here. fyy equal to the integral of xyy from the -infinity to y here. And we've already know that this range includes the point -1. So we can just write the integration like this. So integration from the first part is we need to integration this function from the both side of y equal to -1, from the both side of -1. So we can just simply get the get integration should be like this. Like this, and then we integrate this. Then we integrate this the second part, this part, from the -1 to y, like this. Like this. After we integrate, after the integration, we can find that fyy equal to the 1 minus fx 1 minus y should be like this. So this circumstance, the probability distribution function of this circumstance should be like this. And the other part we need to discuss is when y greater than 2, the fyy should be 0, which is undoubtable, because we already know that, yeah, y when y located the range outside of the range between the -1 to 2, the fyy, the probability density function should be 0. So undoubtedly, when y greater than 2, the fyy should be 1. And the last part we need to discuss is when y located the range between 0 to 2. We can tell from the probability density function here, when y equal to 2, it should be like this, fx0, it should be fx0 here. When y greater than 2, the fyy equal to 1. So this part should be 1 minus fx0. So when we moved from the left of the y equal to 2 to the right part of the y equal to 2, the fyy should be at fx0. And we already know that when y greater than 2, the fyy should be 1. So the neighboring part, when y located the range between 0 to 2, the fyy should be 1 minus fx0. And we can just, based on what we discussed here, to sketch the diagram of fyy here. So that's all.